Here we're asked first of all to express TA and TB in component form. Well, to do that we find TA is simply each of the A coordinates minus each of the T coordinates, so 23 minus 28 is minus 5. 0 minus minus 15 is plus 15, and 8 minus 7 is 1. And for TB, similarly, we take the B coordinates minus T coordinates, so minus 12 minus 28 gives us minus 40. 0 minus minus 15 gives us plus 15. 9 minus 7 gives us 2. And then for part B, to calculate the angle theta between the two vectors TA and TB, we can use the dot product that says, if you look at your formula sheet, A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between. And also the dot product A dot B is defined as A1 B1 plus A2 B2 plus A3 B3, where A and B are two column vectors with the components A1, A2, A3, B1, B2, B3. So in our case then, well, we should say TA dot TB is going to be the sum of the products of the individual components. So minus 5 times minus 40 gives us plus 200. 15 times 15 gives us plus 225. And 1 times 2 gives us plus 2. And they are equal to the magnitude of well, the product of the magnitudes. Well, that's a bit like using Pythagoras to find the length of hypotenuse. For a three-dimensional vector, it's the same principle. It's the square root of the sum of the squares of the components. So for TA, the magnitude is, these parallel lines indicate the magnitude of the vector, is given by the square root of the sum of the squares of the components. So square root of 5 squared, which is 25, plus 15 squared, which is 225, plus 1 squared, which is just 1. Let's make a bit of space for this. So we have that times the square root of the sum of the squares of the other vectors components. So minus 40 all squared is going to be 1600, plus 15 squared, that's 225, times 2 plus 2 squared, so that's plus 4, times cosine of theta, the angle between. Therefore, we can say that cosine of theta must be equal to this lot here, which is 427 divided by the square root times the square root. So here we have 251, or root 251, times this here, the square root of 1829. So we can work that out in Excel. So we want the inverse cosine, if we can find that. So arc cosine of 427 divided by square root of 251 times 1829. So 0.5 for square root, power half. So that gives us the angle in radians, and to convert that to degrees we need to multiply by 180 divided by pi, which gives us 50.93 degrees, or 51 degrees to the nearest whole degree. So this is approximately 51 degrees.